Alright, well, we're going to talk some more about polynomial functions and their graphs in this section. So this is a good outline or strategy for factoring polynomials. You're always going to look for a GCF first. If you have a binomial, two terms, it might be a difference of squares, sum of cubes, difference of cubes. If it's trinomial, three terms, you can do the A and C squares, the perfect squares, the guess and check, or the AC method. And if you have more than three terms, try to do it by grouping. And later on I'll give you synthetic division to use as well, but not today. And remember, our zero product property says that if things are multiplied together equals 0, that at least one of them equal to 0, and we actually set them all equal to 0 and solve. So this is solve a quadratic by factoring. It's already in a factored form. They were nice to us, so we know that 4x minus 1 equals 0, or x plus 6 equals 0. We have 4x is equal to 1, or x is equal to 1/4. This is x is equal to negative 6. Alright, so this one, they weren't so nice, so has to be set to equal to 0 to solve. And then I'm going to factor this guy. So x, 9, and 7. The bigger one, it needs to be negative. So x plus 7 equals 0, or x minus 9 equal to 0. So x equals 9, or x equals negative 7. Alright, all stuff we've seen before. Polynomial functions of degree 2 or more have graphs that do not have sharp corners. Recall that these types of graphs are called smooth curves, and polynomial functions also display graphs that have no breaks. Curves with no breaks are called continuous, and shows a graph that represents a polynomial function and a graph that represents a function that is not a polynomial. So I was taught to, if for continuous, you put your pencil on it, and if you don't pick your pencil up, then it's a continuous graph. This, we're bebopping along, everything's great, but then, oops, we have to pick our pencil up to go over here, so this is not continuous. So, which ones of these are polynomials? So this, that's a polynomial. This is a polynomial. This has a sharp turn, so this is not a polynomial. And this, I have to pick my pencil up, so this is not a polynomial. Okay. Recall that if f is a polynomial function, the values of x for which f of x is equal to 0 are called zeros of f, or also intercepts. If the equation of the polynomial function can be factored, we can set each factor equal to 0 and solve for the zeros. Alright. So right now we can have three cases that we're going to have in this section. The polynomial can be factored using known methods, GCF, and trinomial factoring. The polynomial is given in factored form, or technology is used to determine the intercepts. So, given a polynomial function f, find the x-intercepts by factoring. You set f of x equal to 0. Factor out any common monomial factors, GCFs. Factor out any factorable binomials or trinomials. Set each factor to 0 and solve for the x-intercepts. So I have a GCF here. I can take out x squared of each term. And then this is a quadratic like equation we talked about before. So that's x squared minus 1 minus 2. This is x squared, x minus 1, x plus 1. And this is, well, we'll just leave it like this. I can factor it. See, I'm thinking about it. And so I start writing it. I'm just going to leave it like this for now. So now x squared can equal 0, x plus 1 can equal 0, x minus 1 can equal to 0, x squared minus 2 can equal to 0. So this is x equal to 0, x equal to negative 1, x equal to 1. This is x squared equal to 2, or x is equal to plus or minus the square root of 2. And these correspond to the points 0, 0, negative 1, 0, 1, 0, square root of 2, 0, negative square root 2, 0. And here's the graph of what we just did. So the graph of x to the 6th, 3x to the 4th plus 2x squared. And you're like, well, you just told me in the last section that we'd have this many turning points and this many intercepts. And I have 5 intercepts, and it's degree 6. Well, this guy right here, where we talked about what happens when you go through an intercept, the multiplicity. So actually, when we had the x squared equals 0, that happened twice. Because x times x equals 0, so x equals 0, x equals 0. So that's why instead of going through, it bounces back up because it has a multiplicity of 2. Alright. Let's find the x-intercepts.